Welcome to Thuma Mina Teaching. You are tuned into grade 9 mathematics. Let's have a look where we are at in the curriculum. Today we'll be discussing the perimeter and area of polygons. So let's have a look at perimeter. The perimeter is the sum of the lengths of all of the sides of the specific shape that we are working with. Let's say, for instance, we have a few sheep in a sheepfold. There, where the sheep can eat the grass on the inside of the sheepfold, is the area, and the fence of this sheepfold is the perimeter. We measure perimeter in millimeters, centimeters, meters, or kilometers. To calculate the perimeter of a square, we already know that all four sides of the square are equal. Therefore, we can just add all four of the sides together to find the perimeter. Or we can say 4 times side. For a rectangle, we know that two pairs of opposite sides are equal. Therefore, I have two lengths and I have two widths. So to calculate the area of the rectangle, I can say 2 times length plus 2 times width. To calculate the perimeter of a triangle, I just add all three sides together. For a trapezium, I once again just add all of the sides together. For a parallelogram, I once again have two pairs of opposite sides that are equal. Therefore, I have 2 times A plus 2 times B. For a kite, I also add all of the sides together, and I know that the adjacent sides of a kite are equal. So I have 2 values of A plus 2 values of B. Let's have a look at a few examples. Determine the perimeter of this square. One side is 5 centimeters. We know, since it's a square, that all four sides will be 5 centimeters. Therefore, I can write that my perimeter is equal to 5 plus 5 plus 5 plus 5, or I can just write it's 4 times side. Therefore, it is 4 times 5. Which gives me an answer of 20 centimeters. To determine the perimeter of this rectangle, I know that the two pairs of opposite sides are equal. Therefore, this side is also 3 centimeters and that side is also 4 centimeters. Therefore, my perimeter is equal to 3 plus 3 plus 4 plus 4, or 2 times 3 plus 2 times 4. 6 plus 8 is equal to 14 centimeters. Determine the perimeter of this parallelogram. Once again, I know that two pairs of opposite sides are equal. So, this side is also 2 millimeters and that side is also 4 millimeters. To determine my perimeter, I just add all of the sides together. Therefore, 2 plus 2 plus 4 plus 4, or 2 times 2 plus 2 times 4, which gives me 4 plus 8 and leaves me with an answer of 12 millimeters. To determine the perimeter of this kite, I know that a kite has two pairs of adjacent sides that are equal. So, this side is also 4 millimeters and this side is also 6 millimeters. Therefore, my perimeter is equal to 4 plus 4 plus 6 plus 6, or 2 times 4 plus 2 times 6. That is 8 plus 12, which gives me an answer of 20 millimeters. As we have already said, when we have sheep in a sheepfold, there where the sheep can eat the grass, we call the area. The fence around this area is called the perimeter. Area's units are millimeters with an exponent 2, centimeters with an exponent 2, meters with an exponent 2, or kilometers with an exponent 2. We call this square millimeters, or square centimeters, square meters, or square kilometers. To determine the area of a square, I once again know that all sides of a square are equal. Therefore, to determine the area, I can say side squared. To determine the area of a rectangle, I need my length and I need my width, and I multiply them. So to find the area of a rectangle, it is length times width. Let's do some examples. Determine the area of this square. Since I know that this is a square, I know all sides will be 5 centimeters. Area is equal to side squared. Therefore, 5 squared, which gives me an answer of 25 square centimeters. Remember to write your units. Now determine the area of this rectangle. To determine the area of a rectangle, I know it is length times width. Therefore, I can write 3 times 4, which gives me an area of 12 square centimeters. To determine the area of a triangle, I need to say a half times base times height. It is very important to know which side is the base and which part is the height. The height is always my perpendicular height. The base is always the side on which the perpendicular height is drawn. Let's look at this example. Over here I have a triangle, with the dotted line being my perpendicular height. Note that it is not a side of the triangle, but this gives me my perpendicular height of this triangle. The base is always the side on which the perpendicular height is drawn. Therefore, this will be my base. When I have another triangle, I see that this triangle is a bit skew and it has no 90-degree angle on the inside of it. Therefore, this dotted line provides me with my perpendicular height. But which side is my base now? Since my perpendicular height is on this side, this will be my base, not including this dotted line. Therefore, only the solid line will be my base, as only the solid line is my real triangle. The dotted line does not form part of my triangle. Therefore, this little piece over here is my base. A third example, once again having my perpendicular height, this will be my base, as the 90-degree angle rests on this side. Let's determine the area of this triangle. I know that area is equal to a half times base times height, which is my perpendicular height. I see that my perpendicular sign is on this side, and therefore this will be my base. So I can write a half times 10 times my perpendicular height, which is 7. Therefore, it's a half of 10, which is 5 times 7, 35. Now I don't have units. They didn't tell me if it's millimeters, centimeters, meters, or kilometers. So I need to write units squared. Therefore, I can say the answer is 35 square units. Now let's determine the area of this triangle. Once again, I need my base and I need my height. I see that this will be my base and this will be my height. The problem is I don't have the values of my base or my height. I only know that the entire side DB is 35 units, the entire side AB is 37 units, and the entire side AC is 13 units. I need to calculate my base and my perpendicular height. Another problem I have is the fact that I cannot use the theorem Pythagoras unless I have a right-angled triangle. I cannot use Pythagoras in this triangle as there is no 90-degree angle on the inside. Therefore, I can only use this big triangle and use Pythagoras to determine the length of AD. Therefore, I can say that AD squared is equal to 37 squared minus 35 squared. Writing my reason, Pythagoras. Therefore, AD squared is equal to 144. To find only AD, I have to square root both sides. Therefore, AD is equal to 12 units. I immediately insert this on my sketch. Now, I have my perpendicular height. I still need my base. For me to find the base, I know that CB is equal to 35 minus this dotted line. So therefore, I need to first calculate the length of that dotted line, CD. I see that I have another right angle triangle over here, triangle ACD. Therefore, I can calculate DC. CD squared is equal to 13 squared minus 12 squared, Pythagoras. Therefore, CD squared is equal to 25, giving CD a length of 5 units. Now I can say that side BC is equal to 35 minus 5, which gives BC, which is my base, a length of 30 units. At last, I can determine my area. Area of a triangle is equal to a half times base times height. My base I have calculated as 30 units and my perpendicular height as 12. Therefore, the final answer is equal to 15 times 12, which is equal to 180 units squared, which means my answer for area is 180 square units. To determine the area of a trapezium, I say a half multiplied by my parallel lines added together times h. A trapezium always has one pair of parallel lines, and I add those lines together, multiplied by a half, multiplied by my perpendicular height. Let's determine the area of this trapezium. I know that area is equal to a half times AD plus BC times perpendicular height. Therefore, a half times 10 plus 25 times 12. A half times 10 plus 25 is 35 times 12. And this gives the final answer for area as 210 square millimeters. To determine the area of a parallelogram, it is quite easy. I simply need my base and the perpendicular height, and I multiply them. So area is equal to base times height. Let us then determine the area of this parallelogram. I first need to determine my base. My base is always the side on which the 90-degree angle is. Therefore, this green side will be my base of this parallelogram. I know that my base is 13 centimeters long, as the opposite sides of a parallelogram are equal. Therefore, I can say that area is equal to base times height, which is 13 times 12, and gives me an answer of 156 square centimeters. Our last shape today is the kite. To determine the area of a kite, I say a half times D1 times D2, where D stands for diagonal. A diagonal is a line coming from one angle moving to the opposite angle, as well as this diagonal too, which starts at this angle moving to the opposite angle. Therefore, if I have the length of this red diagonal times the length of this blue diagonal times by a half, I can find the area of a kite. Let's look at an example. Determine the area of the kite. Since we see that this entire length is 16 units long, I know that my diagonal on the inside will be 16 units long. Since they also give me that my horizontal length for this kite is 20 units, I know that this diagonal will be 20 units long. So, the area of this kite is equal to a half times D1 times D2, which means it's a half times 20 times 16, which gives me an answer of 160 square units. Here follows an opportunity for you to practice what you've just learnt. Do the following 7 examples and remember, the answers will follow. See you next time when we'll be discussing the perimeter and area of circles.
We hope you benefited from this video lesson. Our vision at Thuma Mina Teaching is to accelerate access to quality education. And our dream is to see learners across South Africa flourishing academically. We are a non-profit company and we are entirely dependent on public support. We produce lessons at the rate at which they are funded. As soon as a lesson is funded, it is published to the entire growing audience of Thuma Mina Teaching. Please consider taking hands with us in one of the following ways. Share our content with others that can benefit from it. A great way to support us is to find us on My School and to add us as your beneficiary. And consider donating towards a lesson or ask your company's CSI department to partner with us. We are a PBO, so your donation is tax deductible. Our contact details you'll find on our website www.tmteaching.co.za. If you want to reach out to us, please email us on admin@tmteaching.co.za.